Hello, everyone. So, before we basically steamroll it all, I will just quickly ask you two things. First of all, is here anybody who somehow solves DevOps or something similar? CTO, developer operations? Yeah, I see some hands. Perfect, thanks. So the talk will be for you and hopefully for the others as well. I will start with a question. And the question is, what do you need in order to be CTO, sales, key account, and the DevOps guy in a company at the same time and not die from it? And my answer, as the speaker who were before me here said as well, basically, is that the answer is the automation, yeah? That's the only way how you can survive this, yeah? Because I have all those 4 roles in my own company. Who am I? My name is Tomáš Jukin. I am Inza on Twitter, and I am CTO and co-founder at Juicymo. Juicymo is a company which makes mobile and web applications, and we make them juicy, as our name says. I'm expert, I have some background in Ruby on Rails, the web apps development, the backend part. I am guru on Swift, the iOS apps development as well, and I love developer operations, stuff like Kubernetes, traefik, and many more, as you will hopefully see. And I am a big fan of big data as well. Stuff like Kibana, Elasticsearch, those I don't like too much. Much better are Influx, Grafana, etc., etc. So these are the things I am covering basically in my company. And we will slowly continue. Basically, when you ask some CTO about the state of their developer operations in their company, or how they understand it and stuff like this, they will show you or try to explain you something like this. Awesome, epic garden, everything automated, pipelines, continuous integration. Yeah, very nice. Those builds under 10 seconds, yeah, gorgeous. But the reality is very often quite different. In real, when you go inside that company, the situation is usually like this. Yeah? Not there yet. Yeah? There are some trees here around, but there is a difference between this and that garden. So today, I'm going to share with you some ideas how you can change this to that fancy garden, yeah? Some basic steps, but hopefully they will help. And as an example, I will not do just some crazy theory. I will showcase my very own company, how we do that at Juicymo, yeah? We are a smaller company. We are a company of 10 people, but our developer operations and systems and processes are quite advanced. I'm not sure if that is good or not, but I love this kind of stuff, so that's the very reason why they are so advanced. But when they are, I would love to share it with you so you can change and improve your lives as well. So first of all, how developer operation in this kind of agency-like company looks like. Let's take a look on the set of tools such company needs to have somehow. First thing you need as developer company is some kind of issues tracker, aka bug tracking system where you will track tickets, the work, yeah? For that, we use this fancy guy, yeah? Later I will show all the names of the systems. And the most important, yeah? With a company of size of 10, we have refused a little bit to pay like, I do not know how many thousands of dollars per month on those software as a services, yeah? As Vraťa before me already said, those tools, they are costly, yeah? They are not cheap. So we choose different way, and that way is to have everything open source, like to use open source and to host it on your very own infrastructure. But the only way how you can achieve that without being killed by it, while being the CTO, sales, blah, 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 many other hats at the same time, is utilizing that automation. So let's continue. Then you usually need some kind of CRM, customer relationship management software. Then what I personally love, you need ERP. You need to see what about the money is going, how the workforce of your people is planned, etc., etc. And you need to know, hopefully, that you will not bankrupt in the end of the month. Then you have some kind of Dropbox supplement, something to share files. We mainly do code, and we have special software for that, the SCM manager. But there are those weird things like graphics, design, and those are usually big, and they little bit like suck when you put them into Git, There are some ways how to mitigate that, the Git large file system, but still we decided that we need some cloud storage as well. Then you need something to talk, and I don't mean Skype, we actually are not remote, we have an office and entire crew is in that office most of the time, but you need something like a Slack is, and there is one much better Slack, I will show in a moment. Then you need continuous integration server, without it, you would be doomed, That's my best friend, this guy. And you need another best friend that when things don't go straight, don't go awesome, sometimes it happens, you need to catch the majority of the bugs as soon as is possible, to catch them early, and my another friend, Sentry, helps us with that. Then you need to have some kind of presentational website, For me as a DevOps guy, that is trivial, but on the other hand, those designer ladies and UX ladies we have on board, and my CEO, another lady by the way, they love this kind of things as well, so we have a presentational website. And this I don't like personally, but we have to have some mail and docs and this kind of stuff, And yes, I admit, we use G Suite for that, and that is software as a service. We are not really going to like redo that, or I didn't found any other better or cheaper open source solution for that. So let's disclose the names. As a system for work management, the ticketing system, we use open source called Open Project. As CRM, we are using Fat-Free CRM. ERP, we tried some stuff, but then we decided to patch together a very simple, small app in Ruby on Rails and done. So it's like internal tool, but once maybe when I will meet enough people and they will tell me, hey Thomas, this is not piece of shit, we will open source it as well probably. As a cloud storage, we use C-File, and as source code management, we use GitLab. GitLab, my friends, is awesome. It's your another best friend. And GitLab actually could kill most of those things, could replace them, but not in that open source version, sadly. And they have paid version. I don't actually have nothing against that when there is tremendous amount of value, but it doesn't have to be crazy. The payment of the ultimate edition of GitLab, they have payment solution hosted and a solution which you run as on-premise on your own infrastructure. The cost is the same and it's awful. It's like $100, aka $99 per user per month. Not per year, per month. And for a company of 10 people, that is just killing. So we are 100% content users, but only of the community, or how it's called, version of GitLab. And we have it hosted as well. Then, as I already described, we have Mattermost, That's the better Slack, So when you are not happy with Slack, or you simply would like to own your very own data, I say give it a try, it's awesome. Then we have the Drone CI as an integration server, and we have the Sentry as crash reporting. We have our very own Ruby on Rails website built on Spina CMS and custom graphics. And yes, the G Suite is kind of software as a service. You know probably that one. Okay, so this is the basic things, but there is more, little bit, not too much. We love big data and Internet of Things. And those two comes with some other tools we need to host somehow in our infrastructure. We have the ELK stack, Elasticsearch Kibana Logstash. I don't recommend it. It's awful. If you can live without it, do it. On one project, we really had to have it. Then we have Influx, Grafana, technically even those new things like chronograph, telegraph, and capacitor. Yeah, I love these names. Yeah, those guys are super awesome. And regarding Internet of Things, we have the Node-RED implementation, some MQTT brokers, and traefik. This another, I don't know what is it actually, hamster, or what is this, Gopher from the Go language. Yeah, that's that guy I love, yeah, especially when he's suited like this. That's the, when you guide the airplanes to land, and traefik is awesome software. I will talk about it in a moment, yeah? You have even the names on the slide as well. Okay, so this is some tools and services we need as a company. But what next? Is it all? It is not all. We actually are making some apps for our clients, and for that, we need some other infrastructure. We do mobile apps for iOS, Android, native. That is more or less okay because that doesn't run on the company infrastructure, right? Then we do some web part, yeah, some web applications. They have front ends, they have back ends. We utilize the Postgres database as proud Ruby on Rails developers. And all those things have to live somewhere on a staging. We use the Doku for that. And then they are moved to a production, and for that we use another software as a service called Heroku. That's awesome platform, you just need to have a lot of money. And for those cases where there is not this pile of money on side of the client, we have another solutions based on traefik, Docker, and Kubernetes. We basically utilize nearly 100% open source technologies. Yeah, the exception is the Google Apps, and maybe some software for invoices, yeah, and this kind of stuff. We host it on premises, everything on 7 VPS, whatever, yeah, I don't know how to, make the plural from that. And they are hosted at the DigitalOcean, yeah, so the VPSs are kind of service as well, yeah. We do not own, and we are proud on it, we do not own a single piece of hardware for infrastructure. Yes, we do own, like, 12 monitors and 2 Mac Minis, which are in the office, but other than that, we do not own any servers, yeah? And that I would like to recommend to you. Okay, so let's take a look about how this is connected or how it works actually on this typical application we make, yeah, this kind of agency makes. I have 2 examples of users, yeah. In my case, they are both Divoženka. In Czech is like wild girl or something like this, yeah, because I hate those stereotypes that the users on the diagrams have to be always men's or unigender or this kind of thing. So let's take a look. When we go back to that initial image, yeah, the native apps, as you see, went a little bit like not so important, yeah. So let's see how it looks like. This is example of typical setup of a web application which has a mobile app as well, yeah. I have borrowed few of the things from one of our case studies. That's another lecture or talk I had at Web Expo conference, but there is a video from it for those who are interested. But we can clearly see that we have our user. She is accessing the web application front end and some mobile app. The front end has logically the web application backend as well, some administration API. Usually there is some kind of monitoring. And the web application is usually connected. Today, we do live in a connected world, right? So it can be connected to a bunch of other services, yeah? Things like and those ugly stuff, yeah? Okay, so this is the, let's say, kind of what the heck is in point of view. But let's see another one. The one the DevOps care most or more, and that's this one. In order to have such application running, I somewhere have to have my application server who is running the main part of the application. The application has to have a database. Then, when I'm not dumb, which I actually recommend to you as well, I am offloading whatever can be offloaded from the front servers of the application to the background jobs processing, yeah? We have this fancy bulldozer here that I like. In our case, it's the sidekick in the world of Ruby on Rails. And that guy is taking care of all those ugly stuff which can delay your users, like email sending, PDF generations, storing uploads to Amazon S3, yeah? And this kind of stuff. On the other side, we are not done. Yes, theoretically, I could send my two nice ladies directly to the web application, but I won't do that, yeah? That would not be scalable, yeah? In fact, what I would like to have some kind of reverse proxy cache in front of the application, which is connected to memcache in our situation as the actual caching solution. And in front of that is reverse proxy load balancer. Now, please notice that here I have the scalable. That means that I am running multiple instances of those guys, yeah, as well of those guys. My bulldozer is communicating with the web application utilizing the Redis database, Redis key value storage. And here I have this fancy HA. What the heck that means? That means high availability. That means that my Postgres, in fact, needs to be scaled as well. And what the heck is this? This is what I love the most, yeah? When you do it properly, your database, because this is a joke, that is a joke. I can lose that data pretty much. Yeah, this I can use anytime. It's just a cache. It will rebuild. When I lose this, it sucks a little bit. But when my application is done in a smart way, it is just a queue of tasks which should happen in background. Yeah, I can actually reconstruct that if I like. Yeah, but I don't like to lose the Postgres, my friends. Yeah, that's the very place where the main part of data is. So that is the reason why when I am smart or I have super important application, and we have done some of those applications for our clients, I would like to have a real-time or near real-time replica of this database and preferably in another data center, yeah, for sure on another server and stuff like that. Okay, so let's disclose these two friends, yeah. We are using nginx here and traefik. There are some other options, yeah, depending on the amount of load you need to get. Okay, so this is some kind of idea. In a moment, we will dive into this image or use it as well, yeah. But in the meantime, we need to take a different view on the topic. You have seen what the DevOps of a company should solve, yeah, or which components are in play. But now, let's discuss how the heck I can manage all this messiness, yeah? I have 6 tools for that. Our entire infrastructure runs on the Ubuntu Linux. We have everything in a Docker containers. We are utilizing this fancy octopus for anything which doesn't have to be scaled to the heaven. So for managing those Docker containers, we use the Docker Compose, not on production of like high-level things, yeah? We are utilizing Git, from where pretty much we load any kind of source code or deploy. And for the deployment of Ruby on Rails web applications, we use the Capistrano. And because Docker is a friend, by the way, whoever here from my awesome audience, from among of you, whoever used Docker or know what is it? Nearly everybody. Very nice, yeah? So, few of you probably know and understand that it is not good idea to take the Docker container and make it publicly accessible, yeah? Over some, I don't know, HTTP, HTTPS. Yeah? Instead, you would like to have something in between, yeah? And this something in between is traefik. That's the best one I can recommend. Okay, so these are my little hammers nails and stuff, and how I will manage them. Yeah? I will manage them, and I am managing them through the Ansible. That's another fancy tool I would like to recommend to you all. This is my little, I don't know, velociraptor solving everything for me, yeah? You should, my friends, never ever need to SSH to your VPS manually, yeah? Instead, you should just write Ansible playbooks and run them, yeah? That's the only way how you can create a sustainable infrastructure. Okay, so let's take a look back to my image, my slide with the systems. How we host them, how we do it. So the best solution would be something like this, yeah? I don't need to care about G Suite, that's hosted somehow by Google. The GitLab, that's a little bit fucked up, yeah? I mean, that thing just loves to run on the server by its own, yeah? You can Dockerize it somehow, but it's awful, yeah? I recommend just stick with their omnibus solution, yeah? For like low-level instances, for bigger instances, just plant it to Kubernetes. We will talk about that later. But what we do, we have it on a VPS on its own. Everything else should be running in Docker. How it's distributed among our VPSs, as you can see, I have running many of those services on one VPS, on one Docker. I have special VPS for this guy because he consumes a lot of disk. The integration server, by the way, Drone is completely Docker-based. It's a big fan of Docker on its own. He needs his own VPS because he is spawning again and again other Docker containers for making the integrations, actually. The Mattermost is running on its own server. I actually don't know why from this moment, yeah, because I don't want it to have all the eggs in one nest, probably. And GitLab, it's without the Docker on its own VPS, and that one is growing the most, yeah? Okay, so that definitely could work. You can do it like this, and we are doing it like that, actually, yeah? But that's for our own infrastructure where there are no special requirements regarding have to handle, I don't know, 100,000 users and stuff like this, yeah? What about web applications we make for our customers, yeah? We either deploy them to cloud or what to do with them, yeah? So now I have here that image you already know as well. So what is the naive approach? How I will put this somewhere? How I will deploy it, yeah? Okay. I like VPSs, yeah? So let's just put everything on one VPS, yeah? In that moment, obviously, we have to forget about any kind of scalability, any kind of high availability, and this just doesn't exist, yeah? Please notice that I have not put the Amazon S3 on my VPS, yeah? That stayed outside. Okay, what can be like better? Yeah, somebody told me, hey, don't make it directly on VPS, use containers, containerization. Docker is your friend. Okay, I'm going to do it. Bang. I will create one Docker container with everything. Will be awesome. No, this is what they told me, no? No. This is awesome example of bad containerization. This is how you should not do it, yeah? Instead, you should do something like this, yeah? The only way how to tame Docker is to be able to individually control the containers, yeah? To individually scale them. And suddenly, it's much, or not much, but little bit more work at least, yeah? But still, it's like doable. Okay, and now I have like what? 1, 2, 3, 5, 6, 7, 8 different types of Docker containers. Ugh. And this Docker run command line interface is just awful. What I will do? No problem. I have that octopus. Yeah, I have the Docker compose. And I can tame and even little bit scale those guys, yeah, happily with my Docker Compose. And the question is, and this is okay, you can do that for smaller app, you can do that. And we actually, those all Docker containers you have seen before, we are managing through the Docker Compose on our own company infrastructure, yeah? But some clients, they need more, yeah? And more means either deploy it to Heroku Cloud or somewhere else, or we can use container orchestration. We can move beyond that limited abilities of the octopus called Docker Compose. Okay, good. But where then? There are two options: Docker Swarm or Kubernetes. And the good question is, which one to choose? And my answer is the following. Yes, you can go with Docker Swarm. Yeah? It would be like this nice Vespa, yeah? Vespa is very nice, very reliable, very good quality, yeah? You really can go somewhere, you can enjoy the ride, yeah? You can do it. It will be about you, how you will feel, yeah? I'm not sure if anyone wants to have a Vespa. Maybe some of you want to feel that they can do more, yeah? They can do better. They can advance a bit. And then there are Kubernetes. That's a Harley. And if you ask me to choose from, my personal opinion, every single time you ask me to choose between a Vespa and Harley Davidson, I will choose Harley Davidson. And for me, the representation is Kubernetes. As well as Harley Davidson, it's not something you will tame overnight, as well as Kubernetes, yeah? You will have to invest a little bit of your effort, like 3 weeks approximately, to understand every single niche of it. But then, my friends, your reward will be exquisite experience. If we will take a look on our very own poor, small Ruby on Rails application we would like to deploy, how we will approach, like what components will there be in the end. Okay, let's see. So first of all, we need to Dockerize it. Then we need to have those other supporting systems like this Postgres, Redis, Memcache, traefik, and those guys will have their very own Docker containers, and they will be Dockerized as well, yeah? I have the Postgres, and those 3 dots represents all those Redises and this kind of stuff. Okay, but then I have few Dockers, and I should manage them. Remember, we don't like that ugly Docker run CLI interface, yeah? Okay, then my friend of Kubernetes is here. We will manage, we will orchestrate those containers using Kubernetes. But as they say, who will guard the guard? Is it smart to deploy Kubernetes today, in this year, to infrastructure directly, without any guard, without any upper orchestration? The answer is not. It's not smart. I should be better. I should do better. So I will deploy a rancher. Rancher is a tool which basically orchestrates the orchestrator. Yeah? With rancher, you can solve a problem that today you have your very own Kubernetes cluster running on your VPSs. But tomorrow, somebody comes and says, hey, we should move to the Google Container Engine. Oh shit. If you don't have rancher, you are doomed at that very moment. But with rancher, it's not a problem. You simply ask him to move the cluster from one provider to another. and he supports Google Cloud Engine, Amazon AWS containerization engine, and many more, including his very own Rancher containerization engine, which can run on your VPSs. Nice. But there is that important question. How I will install and deploy Rancher? Will I install it like directly? Of course not. It's in a Docker container. Okay, very nice. And you remember what we have said about that Docker run stuff, yeah? Do I really like to have? No, you don't like. You will use our friendly Octopus for that. Yeah? And as you can see, this resembles to me something we have here in Czech Republic, and it's basically came from other countries on the east. I don't know the translation, but the closest one I could remember would be Infinite Mother. Yeah, and we call it like Matryoshka, or if there is, yeah, so I cannot probably repeat, but he knows it at least, yeah? So this is my fancy Infinite Mother. Yeah, and it's somewhat similar, I have to say. Okay, so let's take a look on those Kubernetes. How do they work? There is one important thing, because somebody might say, okay, Thomas, this Rancher seems super cool, right? And I understand all the reasons why you have chosen that Harley Davidson over my Vespa, yeah? But what if I still would like to use the Vespa, but I would like to utilize that beauty of Rancher? I have set information for you. Starting the Rancher 2.0, they decided that they will no longer support that Docker Swarm thingy, yeah? And their reasoning is due to the success of Kubernetes. Yeah, so it's up to you. You still can have your Vespas, but not with Rancher anymore, yeah, unfortunately. Okay, so what about those Kubernetes, yeah? Thomas is saying that it's awesome. What does it mean? As I have said, it's a little bit complicated, but the reward is there. Okay, what the heck? Basically, the Kubernetes works in a way that, first of all, you need to have multiple VPSs. We have a case study. We have our very own, like, other than doing software for our customers, custom software, what we do is that we have a product as a little bit like hobby project. Yeah, it's called thriftygo, and we have decided to run that guy completely 100% on the Kubernetes infrastructure. Our very own Kubernetes cluster running on VPSs from DigitalOcean again. So how Kubernetes works? You need to have a bunch of VPSs, and you will call that bunch a cluster. This will be my Kubernetes cluster. You will pick one of those VPSs, and you will say, you will be the master node, and the rest will be the worker node. Yeah? Okay. And then some cool things will start happen. Yeah? By the way, side note, not sure if everybody here understood that, but Kubernetes is fully open source, 100% free to everyone to use. Yeah? So what will happen on this master node? That is a place where some Kubernetes internal things run, yeah? Because Kubernetes itself is able to handle like many things perfectly on its own. Then you have a bunch of those worker nodes, and they basically look in a very, very similar way, yeah? There is some kind of virtualization of that hardware, some VPS. There is some operating system. Basically, the only thing you need to have there is Docker running. So it's wise to have operating system friendly to that, yeah? There are special operating systems designed for it, but you can have Ubuntu or something similar. Then you have your containerization runtime. We utilize Docker, but you don't have to. There are other options as well, yeah? I cannot remember now the next big competition name, but it's related to the core OS. Maybe somebody knows. Yeah, but there are a bunch of options. Then there is something which is called kubelet and Kubernetes proxy or kube proxy. And that are some other internal parts. This is basically the agent which is communicating with the master node. And then you have your very own containers running there. But what is the best news for you? You don't manage them. Kubernetes do that for you. Oh my God, another epic image. How do I deploy things to Kubernetes? Yeah? So I am here, the developer. Yeah, first thing I have to do is that I have to have my application Dockerized. Yeah, this in smart companies, as Vráťa said in the previous talk, will do your integration server, yeah, and your CI pipeline. You don't have to Dockerize anything manually, or you do not want to. So that will produce my very cute and nice Docker image, and I have to put it somewhere in Docker image registry, like Docker Hub, if I would like to use that, that one which is free or paid, that is the official one, or I can have my very own Docker Hub as a part of my Kubernetes cluster, as we do. Then I will utilize something which is called kubectl. That is a CLI tool which I can use in order to control my Kubernetes cluster. And I will provide some thing called application description, which basically is a bunch of YAML files who describes how your application should be deployed in that Kubernetes cluster. And then the magic will happen. Kubernetes will consume both, and they will start the deployment process. That's the job of the master node. And it will deploy it on the worker nodes. Yeah, there is some bunch of special things in the Kubernetes terminology that the physical computers are understood as nodes. I have my master node and worker nodes. And the thing I am deploying there are not the containers themselves. In the end, they will be Docker containers, but how we understand or describe them is as pods, yeah? PODs, the pods. While one application can have multiple different kind of pods, yeah? Because you need to have a pod for the Ruby on Rails part, for the Postgres, for the Redis, etc., etc. Plus, I can do a magic that I will scale those pods, yeah? Oh my, so many things. So do I have one thing which will represent my application in the end? Close enough. We have a thing called a service which describes multitude of the pods. When everything is deployed, the result is that my application is running somewhere on my fleet of worker nodes. The Kubernetes automatically ensures and checks that my application is scaled, as I said. I, for instance, could say that I would like to have my database like twice, yeah? Or I would like to have one master and two slaves, yeah, in my database, and things like that. And Kubernetes manages both the scaling and distribution on the individual nodes. Yeah, I can, for instance, say that my database should be running in 2 instances, but there will be a rule that please never both at the same node. Yeah, everything like this Kubernetes can handle for you. Kubernetes is also handling the checking and provisioning of all those like images or containers, yeah? When the container crashes, Kubernetes automatically runs a replacement somewhere. Yeah, and why this gateway is important here? Yeah, because the world here, my friends, is really unstable. Nobody knows what is happening here. Like you can take a look, you can take a peek, you can ask kubectl to show me the status. Yeah, but the point is that the Kubernetes itself should manage the fleet of the pods on your fleet of nodes, not you. You are not even able to do so, yeah? So, okay, very nice. I have a bunch of VPSs, each have different IP address. So how I will bring the traffic there? And that is a responsibility of my gateway and somebody else who is called a ingress. Yeah, ingress is a typically HTTP reverse proxy, which is running on every single one of the nodes, and that is directing traffic between or inside that node. And then I have my gateway, which is load balancing traffic against the nodes. Yeah, Kubernetes can handle a load balancer for you as well. It's very nice. Then I need to have a storage. Yeah, there are basically two options. Either move your storage out of the Kubernetes infrastructure. That's the easier approach. Yeah, because the storage has this, ugly feature that it should be like stateful, right? I should not like delete it on demand, yeah, or stuff like this. So either have it elsewhere, for instance, in some external service or whatever, or you don't have to like be set. There is a way how to have it inside that constantly, dramatically, dynamically changing world. You just need a little help. You need another infrastructure like software, which is able to run a storage for containers inside a containers, yeah? And it's awesome. It's distributed and it's great, yeah? And it's called like OpenEBS or something like this. I have a name on the last slide. I never remember, but it's great. It just took us like 1 week to make it running, yeah? But now we can do in 1 hour, yeah? So if somebody will have a problems with that, write me to Twitter, we can get a coffee, I will help you, then send the invoice, and very nice. But I will send invoice for 1 hour of my time instead of 1 week of time of your DevOps guy, yeah? So still, it's worth it. Let's move on. Yeah, this is just another example that I have the physical nodes. There are services, and service consists from multiple different pods. Then we have another funny image about the Kubernetes architecture, which is from another, let's say, direction, that when the traffic comes, yeah, the traffic is processed first by the gateway, but then by the ingress on any of the nodes, yeah? Based on that, it is sent to the right service. The very reason why the ingresses are on every single worker node is that they can reroute traffic when the required service is not on that particular machine automatically. Yeah, it works like a breezy. Then eventually the request is directed to the required like type of application. There is one bad thing which can happen, and that bad thing is, oh, there is not enough amount of machines. I have to scale before I will answer that request. No problem. We have replica controllers and autoscalers for that reason, yeah? We have kube scheduler, and yes, that particular request will be a little bit slower, but in the runtime, ad hoc, Kubernetes can create new instances of the containers and guide the traffic right there. Yeah, and on the back end, I have to somehow manage that things like physical pod placements, etc., etc. You don't have to. Kubernetes is doing that for you, again. Yeah, this is one more image about that replication. Yeah, I have pod templates, and I will just say, hey, create me 10 of that pod, for instance, Postgres database. Nice. Yeah, and this is just another image diving a little bit inside. I will not dive into that because I have just a few more minutes to go. But you are free to explore. This is just how the Kubernetes works internally. So many diagrams, so many hard stuff. So now, a little bit easier topic. Kubernetes have awesome user interfaces to monitor stuff. Yeah, this is called Kubernetes dashboard, and I would not say that it is the best, let's say, achievement on the user interface design, yeah, leak, but it works. If you use the Rancher, in addition, you have a bunch of other interfaces which the Rancher gives you. I have been talking about that thriftygo use case, yeah? it is a mobile application for everybody who likes to give a second chance to your clothes. Yeah, it's about thrift shopping, hauls, and all those crazy stuff. Mainly for the ladies, but even I actually suddenly realized because of this that even many of my friends, and which do not look like to be a thrift shoppers, are thrift shoppers. So if you know everyone, you can recommend. We are currently in private beta. It's a mobile app for iOS, Android with a big API and backend, which is the thing which runs in that Kubernetes. And I'm using it here as a case study. Currently, while in private beta, our Kubernetes cluster for thriftygo runs on 4 VPSs, which I would say is something like minimal configuration. Yeah, we have this kind of configuration, and it costs us 70 USD, like US dollars per month currently. We can very friendly scale. We can scale in a very easy way. One VPS is consumed by the rancher. He likes to be alone. And then we have the Kubernetes cluster running on the rancher Kubernetes engine. And that one is running on those other 3 VPSs, which are a higher configuration. One of those is obviously the master of the Kubernetes cluster. 2 are the workers. We use this OpenEBS, which is the thing you would like to Google, for the storage class. That means that thing to store data, which is distributed in containers for containers. That's like this another example of near infinite mother. We use Helm. That's, by the way, packaging system for, yeah, because I have been talking about those services, but in fact, you will end up with the fact that your app consists from multiple of services. What if I would really like to put it together somehow? You can, utilizing a helm. You know what helm is? That's the thing which a ship has to steer. They have this funny associations as well. And the package for helm is called a chart, like a map in a ship. Yeah, very nice. We use traefik as our ingress gateway. We use a scalable Postgres solution with master and slave, which has load balancing as well between the slaves, utilizing the PG pool. And we have single distributed Redis instance, because Sidekick doesn't like when you have the cluster of Redises. Yes, and last but not least, how we coordinate our traefiks, because there are in multiple instances, and there is a traefik ingress and traefik gateway. We coordinate them by console. So, that would be all from me, my friends. My name is Tomáš Jukin, and I am from Juicymo, and thanks for the attention.
So it was very interesting talk and very energy. I should learn from you. And we have here 2 questions. First one, why don't you recommend the Elastic Stack? How do you manage your metrics?
Yes, thanks. So first of all, best tool to metrics is Prometheus. Yeah, one of the very reason is that it's not flooding and sending, but picking instead. Yeah, so that's regarding the metrics. But we use, in addition to Prometheus, the Influx and Grafana and the ALK stack. Why do I not recommend it? It is a huge application written in Java. When you start that thing, it slowly starts allocate the memory. It is not doing anything for 20 minutes except building indexes. Yeah? And I maybe think that it might be our problem, not the problem of the software, but we never managed to have it like reliably running. Yeah? We have it running on a machine which has 8 gigs of RAM. The thing is running there alone, but it's like not enough for him on occasions, yeah? I have been giving a good example about this in my other lecture about our case study with Harley Davidson. We have utilized this as a monitoring solution. And 1 week before the event, I got highly paranoid and I brought our team to clone everything we had, this big BI on it, into the Influx and Grafana. And thanks God I did it, because there was only one fucked up during the event, hopefully, because of this paranoia nobody else noticed, and that was that this ALK stack went down. And when he goes down, at the moment of traffic, you are doomed, yeah? You will not put it together in time, yeah? And it's super difficult, yeah? Plus, with the same amount of data, the pair of Influx and Grafana, which allows you to achieve nearly the same. It's not so open, it's different time series database versus an index, but it consumes a fragment of the memory. And guess what? It's written in Go, not in Java, yeah? So I'm not saying it's bad. You know, everybody knows that the only thing which is bad is PHP, right? Elasticsearch is good, but for our use case, I would recommend, or similar use case, if you might be in any of such, I would recommend more to go with the Grafana and Influx. But we can talk into more depth after the talk. If you will be interested, ask me. I will love to explain things. Yeah. So that was the question. What is the second one? Or
the second one is why don't drone CI is instead of GitLab?
Yeah, that is a good question, because at the time when we started to use the drone CI, there was no such thing like GitLab CI. And in fact, today or this week, we are in a process of migration from the drone CI to GitLab CI. Yeah, because it has the same features and is superior.
So okay, that's all. Thanks. And now we have lunch. We have 90 minutes for that, so you can go to the tables, there are food, and if you are vegan, you go to the orgs room. This is next to the tables, so thanks, that's all. And sorry, the one, you can get feedback on tablets, and there are 2 guys with tablets in front of the door, so thanks.
Okay, thank you.